zindi mtima umo. Tiende pamozi ndi mtima umo. Tiende pamozi ndi mtima umo. Tiende pamozi ndi mtima umo.
Good afternoon, everyone. Welcome to MTN Zambia. My name is Ernest Kasolo. I'm here to revise you the Science Paper 1, November 2017. In the first part, we need to understand what are the parts that are in Science Paper 1. Science Paper 1 is made up of 3 different parts. The first part, we have 20 questions, multiple choice. And the second part, we have a short answers. And then the last part, there are 3 questions. Then you have to answer 2 questions. And it adds up to section C has 20 marks. However, I ask you to invite your friends and relatives to just like MTN Zambia so that we revise with them this particular paper this afternoon. Again, my name is Ernest Kasolo Mkwesa. Okay, now let's start with the section A, which is a multiple choice. We go back to question 1, A1. Question 1 is saying, which of the following instruments can be best used to measure the internal diameter of a pipe? Now, we should understand that we have 2 types of diameters for the pipe. There is what we call external diameter and internal diameter. So in this case, let's say this is the pipe that you are observing from one end. So from this point here to that point here, this is our internal diameter. And then from that point there to this point here, this is going to be our external diameter. Now, when you look at the instruments that can measure the internal and external diameter, in this case is a vernier calipers. Why vernier calipers? Because a vernier calipers has the lower jaws and the upper jaws. So we see that the lower jaws, they are straight and they hold an object from this point to that point. Therefore, you measure the external diameter. Now, when you clamp it from this point to that point, you see the jaws, they even bend going outwards. These are able to move into the pipe and then they touch this point and that point. Then what readings you are going to get there are for the internal diameter. In this case, our correct answer is B. Vernier calipers is the instrument that we can use to measure the internal diameter. Now, let's move to question A2. Question A2 is on density. This question has come from density. Now, what are you supposed to remember on this particular part? You should be able to remember the definition for density, which is the quantity of matter per unit volume. Now, the question is saying, a stone has a mass of 390 grams and a density of 2.7 grams per cubic centimeters. Cooking oil has a density of 0.90 grams per cubic centimeter. What mass of oil has the same volume as the stone? So looking at this, they've given us the mass of a stone and its density. But for cooking oil, they've given us just the density of cooking oil. In this case, when we find the density, when we find the volume rather of the stone, that is equal to the volume of cooking oil. They need to help us to determine the mass of what? Cooking oil. Now, let's look at this. We are saying volume is equal to mass over what? Density. That is the formula, which is coming from density is equal to mass over volume. So when we make volume the subject of the formula, it gives us volume is equal to mass over what? Density. In this case, the mass of this stone is 390 grams. Then we divide it by the density of the stone, which is 2.7 grams per cubic centimeters. Now when you look at that, the gram and the gram, they cancel out. Then we expect to get the volume in cubic centimeters. When you use your calculator, you find that this gives us 114.4 cubic centimeters. Now, this is the volume of the stone. In this case, this volume of a stone is actually equal to the volume of the cooking oil. Now, it will help us to determine the mass of cooking oil. From the same formula, we now make mass the subject of the formula. So this will give us mass is equal to density times what? Volume. Now, the mass is what we are looking for. Density for cooking oil we are given, it is 0.90 grams per cubic centimeters times the volume of a stone, which is equal to the volume of cooking oil. In this case, it is 114.4 cubic centimeters. So when you multiply that, it is going to give us 130 grams. This gives us our answer to be A. This is the mass of cooking oil that is able to occupy the volume of 114.4 cubic centimeters to give us the density of 0.90 grams per cubic centimeters. Okay, now let's move to the third question, which is A3. A3 reads, the diagram below shows an extract of a tape from a ticker tape vibrator that was connected to 50 Hz AC power supply. Now, determine the time taken between point A and point B. Now, what are we supposed to know here? We are supposed to know that 50 Hz is the same as 50 vibrations that are being completed in 1 second. 50 Hz is a frequency, meaning that this ticker tape vibrator is vibrating 50 times in 1 second. That's why we have that 50 Hz. In this case, look at the points that we have between point A and B. Here they are 10, meaning we have 10 vibrations. So 10 vibrations will give us what? X. We just use direct proportion here. And then from this point we cross multiply. We'll get 50x is equal to 10. Then we divide here by 50. We divide here by 50. That and that goes. X is going to be 50 into 10, and this will give us 0.2 seconds. So this gives us the answer to be B. 0.2 seconds is the time taken for the vibrator to make 10 vibrations. This is how we go about this question. Now, from there, let's go to question 4, which is A4. A4 reads, the diagram below shows a box of mass 2.5 kilograms placed on a table. So you have put an object on the table whose mass is 2.5 kilograms. What force is exerted on the table by the box? In this case, they are asking us to calculate force. Now, when you look at the question here, they've not given us acceleration. In this case, when you are given force and acceleration is not given to you, we use acceleration due to gravity. So we say force is equal to mass times acceleration, and our mass is 2.5 kilograms. We multiply by the acceleration due to gravity, which is 10 newtons per kilogram. So looking at that, We see a kilogram here cancels with that kilogram. We remain with a Newton. Remember, force is measured in newtons. So 2.5 by 10, this gives us 25 newtons. So the correct answer here is 25 newtons, which is the C as the correct answer. Now, from there, we move to question A5. Question A5 reads, the diagram below shows a wheelbarrow carrying a load of 100 newtons by applying an effort of 20 newtons. This question is coming from simple machine. Remember, a simple machine is a device that makes work done easier. So under this, you need to know what mechanical advantage is. You also need to know what velocity ratio is. You also need to know what efficiency is, and then how to calculate these quantities. Now, looking at this question, they are asking us to determine the mechanical advantage. So, mechanical advantage, by definition, is the ratio of load to effort. Now, this can be remembered very well by using the word MEL. Mechanical advantage is load over what? Effort. Remember, these are ratios, and a ratio does not carry unit because you are comparing two things in this case. So, what is this? We are saying MA, which is mechanical advantage, is equal to load over what? Effort. Our load is what is being carried in the wheelbarrow. So what is being carried in the wheelbarrow there? We see it is 100 newtons. So we have 100 newtons. Then we divide it by the effort that is being applied there. So the effort is 20 newtons. Now, a newton cancels with a newton. That's why it will not have a unit in this case. Then we have 20 into 100. That gives us what? 5. So the mechanical advantage in this case is 5. Right. Let's move to question 6. Question 6 is saying, the diagram below shows a beam pivoted at one end and the force of 5 newtons acting on it vertically. This is moment. This is coming from moment. And remember that when we are talking about moment, there is a force that is being applied at a particular distance. Now, the force and the distance must be perpendicular. If the force is going up, then the distance is going to be horizontal, and the other way around. So looking at that, we have a force of 5 newtons that is being placed at 2 centimeters from the pivot. Every time we are looking at distance, we look at the distance from the pivot to where the force is being applied. In this case, we are saying F1 D1 is equal to F2 D2. Okay, F1 is 5 newtons times distance 1 is the distance from the pivot, in this case is 2 centimeters, which is equal to force 2. Force 2 is going to be equal to the weight of the beam times D2. D2 in this case is going to be the weight of, is going to be the distance. D2 is the distance from where the pivot is to where the weight of the beam is concentrated. Now, our D2 in this case, we have been given, it is the two distances, summing them up, from the pivot to where the F1 is, and again from where F1 is to where the F2 is expected. So this is going to be 2 centimeters plus 3 centimeters, which gives us a total of 5 centimeters. Then from there, we can easily find what F2 is by just dividing both sides by 5 centimeters and also here 5 centimeters. This and that cancels. Therefore, our F2 is going to be 5 times 2 is 10, divided by 5, which gives us 2. So we have 2 newtons that is being exerted at the middle point where actually the weight of the beam is concentrated. The correct answer here is D. Good. Let's move to question 7. Question 7 reads, the diagram below shows a water reservoir used to run a power station of 500 meters. Below it as shown. So we can see the diagram there on the screen. Now when you look at the diagram, we see 500 meters from the power station to the top where the water reservoir is. Now the question now says, if the mass of the body of water in the reservoir is 10 to the power 11 kilograms, how much gravitational potential energy is stored by the water in this reservoir? So this question is coming on from energy. Okay, now they are asking for potential gravitational energy. So we should be able to remember the formula that we use to calculate the potential energy. So potential energy is given by mass of an object times the gravitational force multiplied by the height. This is the formula that we use for potential energy. In this case, we are given our mass. It is 10 to the power 11 kilograms. Mass must be in kilograms times the gravitational force. We know gravitational force is 9.8, but for calculation, we round it off to 10 newtons per kilograms. 10 newtons per kilograms. Then multiplied by height. We are told the height from the power station to where the reservoir is 500 meters. Now, with this question, they have not told us to evaluate. They've just told us to substitute in the formula. And everything there is going to give us the what? The joules. So the correct answer is going to be D, which is 10 to the power 11 kilograms times 10 newtons per kilogram times 500 meters. Then that would be our gravitational potential energy. Okay, we move now to question 8. Which statement about thermal radiation is correct? Which statement about thermal radiation is correct? Now, first of all, we need to understand what is thermal radiation. This is the heat that is given out by any hot object. Any hot object. If you stand in front of the stove, you are cooking, you are able to get heat. That type of heat is thermal radiation. Now, out of what we are given here, the only thermal radiation that we have is the infrared radiation. Remember, infrared radiation is part of the electromagnetic spectrum. So infrared radiation is an example of thermal radiation. Now, let's move to the next question, which is question 9, A9. The diagram below shows a mercury thermometer whose bulb is immersed in pure melting ice, then in steam from boiling water. Now, when we put a thermometer in pure melting ice, what are we trying to determine? We are trying to determine the lower fixed point of the thermometer. Again, when we place the thermometer in the steam of boiling water, we are trying to get the higher fixed point. So there are two things here, lower fixed point and higher fixed point. Lower fixed point, we use pure melting ice, and then higher fixed point, we use boiling water. And this instrument where water is boiling from, we call it the hypsometer. Hypsometer is where we put the thermometer so that we record the higher fixed point. Now, looking at the question, the columns of mercury are, so in the lower fixed point, we are saying the mercury thread moves 3 centimeters. In the higher fixed point, we are saying the mercury thread moves 23 centimeters. Okay, then from there, the question is, what will be the temperature if the mercury thread moves 8 centimeters? What will be the temperature? Now remember, lower fixed point is the same as 0 degrees Celsius because we are looking at pure melting ice. Higher fixed point, we are talking about this to be 100 degrees Celsius. Now the question is, if the mercury thread moves 8 centimeters, what will be the temperature? So in this case, there is a formula that we use. The formula that we use is the temperature, in this case, is going to be the reading of the thermometer in question, okay, the temperature of the thermometer in question, minus the lower fixed point, in this case, is the reading of the thread when it is in the pure melting ice, divided by the thread in the higher fixed point. In this case, higher fixed point is when we place the thermometer in the hypsometer, minus the lower fixed point, which is in pure ice, times 100 degrees Celsius. Okay, so what is this? We are looking for the temperature when the mercury thread was 3 centimeters, minus the lowest is 3 centimeters, divided by the highest is 23 centimeters, minus again the lowest, which is 3 centimeters, times 100 degrees Celsius. So when we evaluate this, we'll get 5 divided by 20 times 100 degrees Celsius. So this now gives us 25 degrees Celsius. So when the mercury thread was 8 centimeters, then the thermometer there in this case was 25 degrees Celsius. So the correct answer is B. Now let's go to A10, question A10. Question A10 is on waves. It reads, a wave of frequency 1000 Hz. Remember what we said about frequency. This is the number of wavelengths that are being completed in 1 second. Travels through 2 points, P and Q, with a velocity of 330 meters per second. What is the wavelength of the wave? Now, in this case, the most important thing is to remember the wave equation. The wave equation in this case, it says wave velocity is frequency times wavelength. Now, you can either substitute in that, or you make wavelength the subject of the formula by dividing here by frequency, even this side by frequency, so that we say wavelength is equal to velocity divided by frequency. Now, our velocity is given to us. It is 330 meters per second divided by frequency, which is 1000 Hz. And then when you divide that into 1000 into 330, we get 0.33. In this case, it is meters because the wavelength is measured in meters. Okay, don't forget the wave equation, because the wave equation is what is guiding us to answer this particular problem. Now, let's move to question 11. Question 11 is asking us again about the waves. It is saying 3 vibrating objects, P, Q, and R, produce waves in air of different frequencies as shown in the table below. So we see we have an object and frequency. The object is P with 25 Hz. So P has a frequency of 25 Hz. Then Q has a frequency of 1000 Hz. Okay, then R has a frequency of 15,000 Hz. Now here, when you are looking at sound, we actually talk about the normal frequency of which the ear can perceive the sound. So the question is, which of the above objects produces sound that can be heard by the human ear? The normal human ear is able to perceive sound between the frequency of 20 Hz to 20,000 Hz. So anything below this, the ear cannot get it. Anything above this, it will be able to destroy the eardrum. So anything between this is the normal range. Now, when you look at P, P is 25 Hz. It falls within that. So we can have P there, just above 20. Q is 1000 Hz. Again, 1000 is also falling within this range. Then R is 15,000. 15,000 is less than 20,000. So we see also R there. So in this case, we can conclude that all the three, P, Q, and R, are falling within the frequency that a normal human ear is able to perceive. Okay, so the correct answer in this case is D. Okay, we go to question 12. Question 12, the diagram below shows a ray of light directed to a plane mirror at 90 degrees. So we see the diagram there. What is the angle of incidence and angle of reflection for the incident ray AO? So we see that you have a boundary there, and then we have the normal there. Then within the normal, that's where we have the what? The incident ray. Now, before we look at this, let's look at that diagram here. In a situation where this is our normal, then you have a ray here. This is our incident ray. The angle of incidence is the angle between the normal and the incident ray. So this one here becomes our angle of incidence, which is I. Then this angle here is, let's say this angle is X. So for us to find I, we'll say this normal is at that particular angle. This normal is 90 degrees. So if this is 90 degrees, we'll say 90 degrees minus X. This is now going to give us our I. Now looking at this, our I is, we say 90 degrees minus 90, because this is 90. So what does it give us? 0 degrees. So if the incident ray is at the normal, it means that the angle I is 0 degrees. At the same time, the angle R is also going to be 0 degrees, because we don't expect to have that reflection. In this case, we are saying our answer is I is 0 degrees and 0 degrees, and then our R is also at 0 degrees, which gives us the answer to be D. We now move to question 13. Of the diagram given below, of the statement rather given below, which of these is correct? Now, this question is from electromagnetic waves. Now, remember electromagnetic waves, we have gamma, we have X-ray, we have visible light, we have infrared, we have before, of course, we have visible light, we have ultraviolet, then we have microwave, and then we have TV and the radio waves. So looking at this, we see that here we have high frequency, here low frequency, here high short wavelength, here long wavelength. So the question is, the statement which is correct here is microwaves have a longer wavelength than visible light. So we see microwaves to have a longer wavelength than visible light. At this point, let's take a break. We shall continue after the break.
Enyimbo chinapeera ekyalo omwewo.
Without music, our lives would be lifeless.
Music gives the mind wings.
Music refreshes the soul on this journey of life and never dies.
It's who we are. I mean, it's what we do.
It's what we feel.
What would we be without music?
The future of music streaming is MTN Music Plus.
MTN, everywhere you go.
Do you expect more from your internet service? Maybe it's time to switch to MTN's 4G internet. Introducing the next level in high-performance mobile network technology, taking your home or office internet experience to a whole new level while keeping it simple. Get to work by the click of a button or manage your team from miles away. Browse faster, download multiple files, and stream videos quicker with no limits. Get it all done with MTN's 4G internet. So don't let your internet slow you down. Stay online in real time all the time. Get your MTN 4G SIM today and find your nearest 4G zone to enjoy maximum performance of your 4G enabled device. MTN, everywhere you go.
Welcome back. We are continuing with the revision for science paper 1. In this case, it is physics to be specific. So as I said, please ask your friends and relatives to just like MTN so that we revise together this paper. Before I proceed with this, I want to see some of the SMSs that we have received from here. LM Mulongo is asking when are we bringing mathematics? Okay, mathematics will come, we'll be able to communicate with you. Okay, do we have another SMS there? Okay, Sydney Simwanza joined. You have joined us. Please, thank you so much. You are welcome to MTN Teleschool. Okay, do we have another? Okay, Bibian, Guava, Ichigo, you have liked the MTN. Okay, that is beautiful. Okay, I think those are the messages we have received. So we can proceed with our revision here. We are continuing with question A14. Okay, A14 has a transformer. Now remember, transformer is a topic that we cover when we are talking about electromagnetic induction. Now, we have basically two types of transformer. In this case, there is a step-up transformer and a step-down transformer. As the name tells, you can tell what does a step-up transformer do. Okay, so a step-up transformer is able to increase voltage. Then step-down transformer is able to decrease voltage. Now, looking at this, the question reads, the diagram below shows a step-down transformer. So we have a step-down transformer, meaning it is decreasing voltage. So we see the transformer there. What is the size of the current flowing in the primary coil if the bulb is working at full normal brightness? Now, we have been given power on the primary and power on the secondary, and they are asking about the current. So the formula that we use is power is equal to voltage times current. Now in this question, there is one part that is missing, which is making us not to be able to calculate the current in this. We have been given power. They are asking us to find current, but they have not given us the voltage. In this case, current cannot be calculated here unless we are given voltage. Okay, so in this case, understand the formula: power is equal to voltage times current. If you have voltage, you put voltage there, then you substitute the power there. That's when you'll be able to calculate the current in question. Okay, question 15 again is on electromagnetic induction. Now, electromagnetic induction, in this case, they are asking us to say a metal wire is placed between the poles of a magnet. So you have a magnet. Remember, a magnet has a north pole and the other end south pole. So in this case, we have a north pole and a south pole there. Okay, then in which direction or directions must the wire be placed to induce an EMF across the end of the wire? In order for EMF to be induced, it means that the wire must be able to cut from north to south. That's where we have the magnetic field. In this case, the wire must be able to cut the magnetic field. So in this case, the wire must move from the top going down, meaning it is going inside the page and outside the page. So the metal wire must move out of the page and into the what? The page. That's when induced EMF will be what? Will be produced. In this case, the correct answer is OP. It will move OP direction. Right, let's move to question 16. Question 16 is about electricity. Now, when you look at this question, we have been given a circuit there. Let me read the question itself. The diagram below shows an electric circuit with an unknown resistor marked X. So we see an unknown resistor marked X there. And we have two resistors there. One is X, one is 8 ohms. And then we have, of course, our ammeter. Our ammeter there is reading 0.8 amps. That is the current that is being recorded in this circuit. Again, we are given the battery, and this battery has the EMF of 12 volts. That is actually our voltage. So the ammeter, remember, ammeter measures what? Current. In this case, we'll pretend not to know that there is 8 ohm resistor there. So what we are going to do is we'll use current and voltage to determine the total resistance in this particular circuit. We are going to use the Ohm's law formula, which is saying resistance is equal to voltage over what? Current. Voltage over current gives us resistance. So our voltage there is 12 volts divided by our current, which is 0.80 amps. All right. Now, what is this? So this gives us 15 ohms. So 15 ohms is the total resistance that we have in this particular circuit. Now, then let's look at the two resistors that we have. How are they connected? These two resistors are connected in series. If they are connected in series, then we use the formula for series connection, which says RT is equal to R1 plus R2. Now, our RT, we have already calculated it. It is 15 ohms, which is equal to R1 is given by X plus R2 is given by 8 ohms. So when 8 goes this side, it forms negative 8 ohms minus, 15 ohms minus 8 ohms gives us what? It gives us X. In this case, our X is going to be what? 7 ohms. So you can prove this by just adding the two. 7 plus 8, it gives us 15. Now, let's move to question 17. Question 17 again is a circuit which is incomplete. The diagram shows an incomplete circuit. So we see the circuit there which is incomplete, and then they're saying four wires of different length and thicknesses are connected in turn between point X and Y. So we see point X and Y there. If the switch is closed, which of the following wire will cause the greatest reading on the ammeter? Ammeter measures current, as we have mentioned earlier. Now, remember that if the wire is very long, the resistance is high. The longer the wire, the higher the resistance. So in this case, we are expected to have a very short wire. A short wire gives us lower resistance. At the same time, what is the relationship between the thickness of the wire and resistance? The thicker the wire, the higher the resistance. So in this case, if you want the resistance to reduce, use a very thin wire. So in this case, we are talking about short wire and thin wire. This combination will give us a higher current that we expect. Right. Let's move to question 18. A18. Paul has a 2 kilowatt heater. Okay. Here we are talking about the cost of electricity. The Zesco electric meter at this house shows that there is only 3 kilowatt hour units of electricity left. How long will he run his electric heater before the units run out? Now look at this. Here, this 3 kilowatt hour is actually equal to the number of units, because we say 1 unit, okay, is equal to 1 kilowatt hour. This is energy. This is the energy that is in relation to the number of units. So here we'll just say what is 3 kilowatt hour divided by 2 kilowatt. What does it give us? 2.5. What is this? This is actually what? Time. So in this case, sorry, not 2.5 but 1.5. This is heat, and this gives us the answer to be C, 1 hour 30 minutes. Question 19. Question 19 is on radioactivity. What are you supposed to know about radioactivity before we tackle this question? We should be able to remember that we have 3 types of emissions. And the 3 types of emissions are, we have alpha particle. Alpha particle is helium nucleus by nature. We have beta particle. Beta particle is a fast moving electron. Then we have gamma ray, which is an electromagnetic wave. Now, what happens if an object gives out alpha? So if alpha particle is given out, every time alpha particle is given out, we are saying this is helium nucleus. The atomic mass reduces by 4. The atomic number reduces by 2. In a situation where we are giving out beta particle is an electron. If it is an electron, the atomic mass remains the same, but the atomic number increases by 1. It increases by 1. Now, looking at the question, a radioactive element X has atomic mass 222 and 86, emits 2 alpha particles, 2 beta particles, and 4 gamma ray. What will be the final composition of the nuclide formed? Now, when it comes to gamma ray, in this case, there is no change in atomic mass, neither do we have a change in atomic number. So it will not affect the atomic mass as well as the atomic number. So it will still remain what? The same. So we'll look at these two here. According to the question, it is saying we have 2 alpha and 2 beta. Now, what we have is X 222, and then we have 86. So this will give out alpha. Once it gives out alpha, what are we going to have? We are saying the number on top will reduce by 2. Will reduce by 4. Then the number down will reduce by 2. Now, since here it is giving out how many? It is giving out 2 alpha particles. Then we see the reduction in atomic mass by 8. And then the reduction in atomic number by what? By 4. So what we do is we say, okay, when we reduce this by 8, we'll see that we remain with the X 2 and 14. Then down here we remain with the 82, because we have reduced this by 4 and then we have reduced that by 8. Plus the helium, how many of them? There are 2. So here we have 4 and 2, and then we have 2 of these that it is giving out. Now we get again what we have there, which is 214, and then we have the 82. Now here we look at giving out what? Beta. Now what did we say? When a nuclide is giving out beta, the number on top does not change. It still remains the same. The number down increases by 1. So here it is giving out 2 beta. So it is going to increase by 2. So we are going to have 82 plus 2, which is going to give us 84. Then on top there, it will remain the same. Again, plus 2 of the what? The beta particles there, which it is giving out. Now, the question is, how many protons, electrons, and the neutrons are in the nuclide that is formed? So the nuclide which is formed is this one here. So protons are represented by the number which is down. So here we are going to have 84 protons. Then electrons, again the same. The number of electrons and the number of protons in an atom are equal. So we have 84. Then the number of neutrons, in this case, it is 214 minus 84. What does it give us here? It gives us 130. So we have 130 neutrons, 84 electrons, and 84 protons. That's how we go about this question. Again, the last question for multiple choice, which is question 20, is saying the diagram below shows a decay curve for a radioactive substance. So we have been given our diagram here. This is an activity, okay, which is the same as the disintegration. We have the disintegration here, and then down here, what do we have? We have the time. Time is in minutes. how do we determine the half-life of the radioactive substance using the graph? So remember, the radioactive substance runs in that particular direction. It makes a curve, but the curve does not touch the time. So here we have 0. So in this case, what we have there is 8. The activity there is 8. Then we are using that to determine the half-life. What we have on the x-axis are time, in this case in minutes. So we have 8 there, divide by 2. When you divide 8 by 2, because a half-life is the time taken for half of a radioactive substance to decay. So what does this give us? It will give us 40. So we go on 40 and then draw the dotted line to touch the graph, then bring it down. Where it touched the x-axis, that is our half-life. In this case, looking at the question that we've been given, 8 divided by 2 gives us 40. Then when we move towards the curve and brings it down, we see that it is falling up to 10 minutes. So our half-life of this particular radioactivity is what? 10 minutes. This marks the end of the first section, which is the multiple choice section. Now, we are quickly moving into section B. Section B is short answers. Here, you have to fill in the short answers in the spaces provided. So, question B1 and section B is saying, first of all, the instructions are saying, answer all questions in this section. Then write your answers in the spaces provided on the question paper. So we are going to write within the question paper. Now, figure 1.1 shows a simple pendulum. So we've been given a pendulum there, which is being hung in that direction. Okay, and then we are told that this is A, then we have C there, the B is in the middle. The pendulum in this case is able to move from A to C back to A. And such movements, we say, the bulb is making oscillations. It is making oscillations. Now remember, an oscillation is the movement of the bulb, in this case, from A to C and back to what? To A. Now let's look at the question. What is it saying? If the bulb of the pendulum takes 0.5 seconds to swing between extreme positions A to C, so it is moving from A, it goes to C. Okay, calculate the period of oscillation. What does this mean? They are asking us to calculate how long does it take for the bulb to make one oscillation. So in this case, we have a formula which says period is equal to time taken to make oscillations over the number of what? Oscillations. Now, the number of oscillations that are being completed or that are being made in that particular time that we have, time small letter t. So looking at the question here, the time that we have is 0.5 seconds divided the number of oscillations. The bulb has just moved from point A to C, meaning it has made half oscillations. And remember, half oscillations is the same as 0.5 oscillations there. So 0.5 divided by 0.5, this gives us 1. So it gives us 1 second. So the period of this bulb is 1 second. Part B, calculate the frequency of the pendulum. How do you determine the frequency of the pendulum? If you know the period, it is very easy for you to determine the frequency, because frequency is equal to 1 over period. And in this case, we have 1 divided by the period, which is 1. What does it give us? 1 second there. What does it give us? 1 hertz. Frequency is measured in hertz. Okay, C. Part C is saying, state whether the frequency of oscillation will increase, decrease, or remain the same if. So here what you just need to do is to say it will increase, it will decrease, or it will remain the same. If the length of the string is increased, remember, if we increase the length, it will be taking long for the bob to move from point A, it goes to point C and coming back to point A. In this case, we see that if the length of the string is increased, we see decrease in the number of what? Oscillations. Okay, we see that there will be decrease there in terms of the frequency. The frequency is going to decrease. The mass of the bulb is increased. When the mass of the bulb is changed, in this case, the frequency still remains what? The same. When you increase the bulb, it will still remain the same. All right. Let's look at question B2. Question B2 in this case is talking about the distance time graph. We have different types of graphs. We have velocity time graph. In this case, we have distance time graph. Now, as we have seen, the question there, it says, figure B 2.1 shows a distance time graph for a car traveling along a straight road. Okay. Describe the motion of the car between point C and point D. So between point C and point D, we see the car was moving with non-uniform speed. The speed was not uniform. So simply non-uniform speed there. Between which point is the car accelerating? The car, in this case, is accelerating at 2 points. From point A to B, we see an acceleration, and we also see an acceleration from point C to what? To D there. Okay. Now, let's look at part C. CA. State the distance traveled by the car between A and B. Here we just go on to the y-axis and then we look at between point A and B. What is the distance that is being traveled there? In this case, it is simply 10 seconds. So see, state. You don't need to explain. You just to pick the figure there. So this gives us, see, 10 meters. That is the distance that is being traveled at that particular point. Then C2 is saying calculate the average speed of the car between A and D. What is the average speed? Remember, we have a formula. Average speed in this case is saying the total distance covered divided by the total time taken. Total distance covered divided by total time taken. The total distance covered in this case, we see it is 60 meters divided by the total time taken. In this case, at D, we see that it is 20 seconds. And this gives us 3 meters per second. That becomes the average speed that is that this object traveled with during this period of time. Now, let's move to B3. B3 is talking about extension. An 8 Newton force stretches a spring to 20 centimeters. So we see the spring being stretched to 20 centimeter mark rule. If the extension of the spring is 4 centimeters, calculate the original length. Now remember, there is a length of the spring after being stretched and the length of the spring before being stretched. Now, the length of the spring before being stretched is actually what they are asking us here to calculate. Now, what are they saying? We are saying we have 20 centimeters and the extension The extension in this case is 4 centimeters. The question is, what was the original length? So the original length is the stretched, we are talking about the stretched spring, okay, minus the extension. In this case, it is 20 centimeters minus 4 centimeters, which gives us 16 what? Centimeters. Okay. So we end here for this the first part. Join me for the second part at 16 hours. My name is Ernest Mkwesa Kasolo.
Tiende pamozi ndi mtima umo. 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 Tiende pamozi ndi mtima